Okay, so let's stop the music. God, do you notice how I have to stop doing everything? I can't talk, can't do anything else while I can't multitask. That idea of us being able to multitask is a load of old nonsense. I'll keep myself in the corner for a little while. I might turn it off in a while because I think it might affect the quality and it's a little bit distracting. But I think I just sat in a webinar this morning. It's quite nice to see the person that's talking in the corner. So welcome. Thank you for joining us. Rock number 2 in the 12-week lockdown. So we're looking at rock number 2, which is exercise. We will recap briefly the rocks of well-being, and I'll introduce myself. For those of you that don't know me, my name's Andrew, and I work at Action Your Potential in lots of schools, really sharing the amazing news about our amazing brain. It's incredible, the organ we get to live inside. So our seminars are all about going from being a brain slave, living in our brain, just following its little programs, sometimes suffering some of the issues that it generates as it's working, to being a neuro ninja, which means living in our heads, understanding what our brain is doing and how we need to respond. Because as we all know, living inside our brain isn't always a pleasant experience. In fact, they're not designed for happiness. They're designed for survival. So that means they spend a lot of their time worrying about things and tagging problems in the environment with negative emotional experiences. So we're going to look at rock number 2, exercise. That's me, that's the company. But before we do any of that, each time we look at these rocks, so we'll give a little bit of brain science, because actually what we're talking about really with the wellbeing rocks is learning a skill, a new skill, and understanding ourselves in a new way. And that's what all the neuroscience revolution is about, is understanding ourselves in a completely different way using the science. So it means that we can behave in different ways more quickly, and also understand, for example, why it takes us so long sometimes to pick up new habits. And we're going to look at that specifically tonight. We're going to look at the brain as a learning machine and how our children use us and our brains as a proxy in terms of how to work out how to be a very successful human. And then we're going to look at how we can use our mind generated by our brain to change our habits, because our mind and brain are ever so slightly different from each other. So the brain generates the mind, and amazingly, it doesn't work the way it feels that it works. So first of all, let's just look at our children. Amazing, incredible little human beings with their incredible brains. And there used to be this idea in philosophy and psychology that the human brain arrived kind of empty and it was filled up by experiences. And there is absolutely a process of growth and development that occurs in response to the environment. But the best way to think about it is that our nature evolves and changes on the basis of nurture. So nature via nurture. And actually that our brains are little learning machines. They arrive with a set of algorithms that they immediately apply to the world. And we're going to explore that first in this video. I really hope the sound works.
Imagine a world in which infants are trying to make sense of everything. The sight of a face smiling and a voice talking.
Who's a silly Billy?
All of those senses are awake and alive. To me, that's genius. We all are walking around with brains that got forged early in development. Our brains come ready to learn, but they're not completely formed. The infant brain is coding all the time. They're trying to understand, what are the signals that mean I'm going to be fed? What are the signals that mean I'm going to be loved and touched? The baby's learning that when I give the merest hint of a smile, my parents go gaga.
Diva, look here. Felix.
They're computational geniuses, but this computational genius takes place through the social channel that codes the most frequent things that happen in their world. And built into that is the drive to do the things that we do so they can be like us. We evolved to make the littlest citizens in the world grow into the full potential adults they become. And the way to do that is to supply innate curiosity and to start with a brain and senses and cognition that's ready to go on day one.
Tap. Tap says. You want me to tap the same as you?
Yeah.
its hand on it first? Okay.
Yeah.
And we tap it.
Yeah.
As adults, we have lost some of the creativity of youth. We are not the baby walking down the street, enamored by the picket fence and the bus, with this wide open mind that the poets used to talk about. We have narrowed our views. We're less enthralled by novelty. In fact, our brains tend to keep us on the narrow, in the box thinking. And we can already see the decline in the ability to learn like that at 7. There are many ways that we've tried to understand what it means to be human. You can study cave art. You can look at the heavens. And I think one of the best ways is to look at a baby and understand how that baby comes together. We all developed. We all had a childhood. And it indelibly affected who we are today.
So we arrive in the world, not a blank slate, with a whole set of learning algorithms, and our brain gets to work immediately trying to work out everything. So it's predisposed to look at faces, and it begins to work out depth, and it's using these algorithms the whole time. So we're in a process of how can we help our young people build their amazing brains? And we're going to focus on the Wellbeing Rocks today to look at that in a bit more detail. So it's really important to let our kids know, I'm sorry, there's a spelling mistake on that slide, that our brain builds our mind every day. So the brain builds the mind like a projector builds an image. So it's really important to think about that in a particular way. And also to let our kids know that the mental and physical health are the same thing, that the brain is a physical organ. And if we experience any kind of emotional pain, rejection, failure, etc., we feel that in our heads. In fact, that little yellow area there in the anterior cingulate cortex, just behind the prefrontal cortex, is where we register social pain. So sticks and stones may break my bones, but names will never hurt me is not true. Actually, we know that verbal abuse, failure, rejection causes emotional pain. And some of us could be carrying emotional pain around in our heads for years. And the way we get that out is we have to explore our emotions. And ideally for our brains to be able to name the emotions that we're experiencing. But more on that in about 4 weeks' time when we look at Rock 6, emotions. We also need to teach our kids that they've got a neurally plastic brain that changes throughout our lives. So it's constantly shifting and changing our brain, making new connections on the basis of what we use. And for our children between the ages of 0 and 25, their brain has done this amazing process of sprouting lots of synaptic connections. Those are the gaps between nerve cells. We'll look at those again in a second. And then really between the ages of 12, 13 onwards, the brain is pruning back connections, and it's keeping connections that are being used and getting rid of connections that aren't being used. And that's really important. So whatever skills, knowledge that we're using a lot, our brain keeps and says, right, we're using that, that's important. And that might be something like playing the guitar, or it might be overthinking and worrying. Our brain makes no distinction as to whether it's a good or a negative process. It just works on the basis that the environment is requiring this process. Therefore, I'm going to lock that process in to the neural architecture. Our brain is plastic, so we can change that. And we're going to look at that in a while. That's a neuron. And I mentioned synapses. We've got trillions of these tiny little gaps between our neurons. And those neurons and synapses, that's where we live in the structure of our brain. And lots of connections, 1,000 trillion connections possible across our brain. So we've got this neural architecture, and that creates all of our habits. And as we go through these 12 Rock seminars, we're going to look at these truths. Key ideas are truths about the brain that once we understand them, will change our world. And so one of the truths we need to look at is we need to think about ourselves from inside out, thinking about we have a mind and a full consciousness, and that process is built by the brain. And we're really quite special as a species to have this mind and consciousness, because it creates an opportunity where our mind is built by our brain, but it gives us an opportunity to reflect on our experience. But what consciousness is and what the self is isn't exactly how it feels inside. And I want to talk about that because it helps us change our habits once we understand what we actually are. So the mind is generated by the brain, and it lags behind the brain's activities by a few milliseconds. So we're just going to briefly explore this idea of consciousness, because it's really important. If we're going to change our habits, we need to understand what we are, and what we think we are and what it feels like we are isn't exactly right in relation to the brain science. So we're just going to look at what consciousness is, and then look at a weird experience about self. Then we're going to look at Rock 2 exercise.
Here are two images of a house. There's one obvious difference, but to this patient, PS, they looked completely identical. PS had suffered a stroke that damaged the right side of her brain, leaving her unaware of everything on her left side. But though she could discern no difference between the houses, when researchers asked her which she would prefer to live in, she chose the house that wasn't burning. Not once, but again and again. PS's brain was still processing information from her whole field of vision. She could see both images and tell the difference between them. She just didn't know it. If someone threw a ball at her left side, she might duck, but she wouldn't have any awareness of the ball or any idea why she ducked. PS's condition, known as hemispatial neglect, reveals an important distinction between the brain's processing of information and our experience of that processing. That experience is what we call consciousness. We are conscious of both the external world and our internal selves. We are aware of an image in much the same way we are aware of ourselves looking at an image, or our inner thoughts and emotions. But where does consciousness come from? Scientists, theologians, and philosophers have been trying to get to the bottom of this question for centuries without reaching any consensus. One recent theory is that consciousness is the brain's imperfect picture of its own activity. To understand this theory, it helps to have a clear idea of one important way the brain processes information from our senses. Based on sensory input, it builds models, which are continuously updating simplified descriptions of objects and events in the world. Everything we know is based on these models. They never capture every detail of the things they describe, just enough for the brain to determine appropriate responses. For instance, one model built deep into the visual system codes white light as brightness without color. In reality, white light includes wavelengths that correspond to all the different colors we can see. Our perception of white light is wrong and oversimplified, but good enough for us to function. Likewise, the brain's model of the physical body keeps track of the configuration of our limbs, but not of individual cells or even muscles, because that level of information isn't needed to plan movement. If it didn't have the model keeping track of the body's size, shape, and how it is moving at any moment, we would quickly injure ourselves. The brain also needs models of itself. For example, the brain has the ability to pay attention to specific objects and events. It also controls that focus, shifting it from one thing to another, internal and external, according to our needs. Without the ability to direct our focus, we wouldn't be able to assess threats, finish a meal, or function at all. To control focus effectively, the brain has to construct a model of its own attention. With 86 billion neurons constantly interacting with each other, there's no way the brain's model of its own information processing can be perfectly self-descriptive. But like the model of the body or our conception of white light, it doesn't have to be. Our certainty that we have a metaphysical, subjective experience may come from one of the brain's models, a cut-corner description of what it means to process information in a focused and deep manner. Scientists have already begun trying to figure out how the brain creates that self-model. MRI studies are a promising avenue for pinpointing the networks involved. These studies compare patterns of neural activation when someone is and isn't conscious of a sensory stimulus, like an image. The results show that the areas needed for visual processing are activated whether or not the participant is aware of the image, but a whole additional network lights up only when they are conscious of seeing the image. Patients with hemispatial neglect, like PS, typically have damage to one particular part of this network. More extensive damage to the network can sometimes lead to a vegetative state with no sign of consciousness. Evidence like this brings us closer to understanding how consciousness is built into the brain, but there's still much more to learn. For instance, the way neurons in the networks related to consciousness compute specific pieces of information is outside the scope of our current technology.
So basically, there's this idea that the consciousness, it's more than an idea because it's based with quite a lot of evidence behind it, that consciousness, or the sense of self we have, the mind, is a readout. It's like the headlines of how we're doing. So it's our constant update, like the headlines of a newspaper. So the way to think of it is our brain generates our mind, and our mind is milliseconds behind our brain. Why am I going on about this? Because it's about habit change, and we're going to look at that in a while. Because when we're trying to change a habit, we're trying to change an existing neural architecture in our head. We're trying to use our mind, generated by our brain, to go back in and change the neural architecture in our heads. And we're going to look specifically about how we do that in relation to exercise shortly. So this is all very interesting, Andrew, and very philosophical, but actually, what's the evidence for this? Well, there's a fantastic experiment done a couple of decades ago, which looked at this whole idea in relation to the movement of somebody's hand. We're just going to have a look at that experiment, and then we'll get on to Rock 2.
Put your hand in front of you and flex your wrist. You presumably first had a thought, flex my wrist, that then caused your wrist to move. That's how it seems. But Benjamin Libet's experiments in the 1980s have cast some doubt on that. In his neuroscience lab, he wired up subjects to an EEG machine measuring brain activity via electrodes on their scalps, and then asked them to choose to perform a simple hand movement when they felt like it. He also got them to record the time at which they made a conscious decision to move their hands. Disconcertingly, he found evidence of brain activity initiating the movement hundreds of milliseconds before the conscious decision was reported. In other words, his experiments seemed to show that the conscious decision didn't cause the movement. The brain activity bringing about movement started before the individual willed anything to happen.
So that's an amazing bit of information from Benjamin Libet's experiment, that the brain has already decided to move the hand, and we catch up with that decision a few milliseconds later. It is still us, it's still us making that decision, but it's our brain, and our mind runs milliseconds behind our brain. And that's because the mind is a very good working map of what we're doing, where our body is, what thoughts we're having, what's going on out in the world. It's an extended model which constantly changes in response to what our brain's doing. So the brain generates the mind is the image. So the quality of that image day to day is built through this process of learning well-being as a skill. To go back to that idea of children looking at us and thinking, basically, how am I going to run my brain? We need to teach our kids that well-being is a skill. It's not just luck. And there are a whole set of activities that our brain needs us to do every day to be the best that we can. And we know about the 12 rocks of well-being. Half of how we feel every day is down to what we've done in the last 24 hours. And that's the rocks. And last week we looked in detail at sleep. If you want me to send you the webinar for sleep, happy to do that. Just email me once you get this webinar. I'll send this to you in a couple of days. The next rock is exercise. We're looking at that. Our brain needs us to do these things every day. Otherwise, the quality of the mind it generates, and we've just seen that the mind is generated by the brain, the quality of the mind we get to live inside is not as good a quality. And if we don't practice deliberate rest, our 12 rocks of well-being, and build well-being as a skill, we are less efficient, we are less productive, we are more emotional, we are more anxious, we've got less memory. So it's really important to do all of these things. And as you'll see over the course of these 12 weeks, every single one of these rocks there's a lot of nerdy detail behind the scenes about what they're actually doing to the brain. So in relation to the 12 rocks, if we feel wonky, we should look at this list first and say, which of these have I not done in the last 24 hours? Because it's going to affect my brain function. Because me is generated by those synapses and those neurons all humming together, 86 billion of them, 1,000 trillion connections generating my mind. And if my mind's not in the best place possible, it might be because of something that has occurred in my world, but it also might be because I haven't done some of these basic things. And each of those links to an actual process in the brain. So we need to teach our kids that well-being is a skill, and we're all locked down at the moment. So it's a really good opportunity to change our habits. And we'll look at the end about how we do that. So we looked at Rock 1, sleep, last week, so we won't cover that this week, but just look at the impact of not enough sleep. And you know that from your own experience. When you've not had enough sleep, it impacts on you. And if you are a person that struggles with your sleep, do get in touch when I email these out, because I'll send you some advice in terms of getting the most sleep that you possibly can. So hopefully we'll get to exercise. Yes, sorry. So the one bit of habit around sleep, if you wanted to get more of your sleep, just a reminder from last week, is to learn your sleep stride. What is that? Your sleep stride is that moment when you fall asleep in the evening. That moment of maximum sleepiness is when you should be in bed. So investigate when that is. For me, it's about 9 o'clock that I get that wave of fatigue caused by sleep pressure and melatonin being released across the brain by the pineal gland. And if we become aware of when that is, we've all got a natural fall asleep time. Some of us are larks, some of us are owls, some of us are halfway between those two. So really do focus on when you feel asleep, when you feel sleepy, and make sure you're in bed before that happens. Loads of us are up watching Netflix, nodding off, and then falling asleep on the couch, and then not being able to go to sleep when we finally get to bed. So if we can learn our sleep stride, we can arrive in bed at the same time each night, and we'll get to a sleep stride where we're able to move in and out of those processes in a way that means that we can get more sleep. Okay, right, I'll answer your question in a while, if that's okay. That sounds like you're probably getting slightly more sleep than you need. I will come back to you towards the end. Being a bloke, tricky to multitask. Okay, so let's look at rock number 2, exercise. So, you know, I'm a nerd, not a massive fan of exercise until I started researching the brain science. What does exercise do for the brain? Well, it does a number of things. First of all, it generates this chemical called BDNF, which is brain-derived neurotrophic factor. Even 5 minutes of exercise with our heart rate up, it generates this chemical, a hormone, and that hormone causes more connections to be built across from our dendrites, from our neurons, connecting to other neurons. That means we've got more connections, which basically means we've got more cognitive reserve. There are more tracks for the thoughts and feelings in our brain to roll down. And the more cognitive reserve we've got, the more flexibility, agility we've got in terms of our thinking and our feeling processes. So just a little bit of exercise generates a dollop of BDNF, this growth hormone for the brain. What does exercise also do? It causes capillaries to grow into the brain, and capillaries supply lots more blood to the brain. When brain cells, when they're firing, need more oxygen. So it stimulates the growth of capillaries in the brain, which increases the blood flow, which increases the ability of those brain cells to get the energy they need, which increases the efficiency and productivity of those brain cells, increasing the efficiency and productivity of our brains. What does exercise do for our brain in terms of mood and concentration? A little bit of exercise improves our mood, improves our concentration and ability to focus. You could snack on exercise through the day. A brisk walk or a little bit of exercise will increase your concentration and attention if it's flagging. And that's been an effect that we've seen in a number of studies across the world. It increases your concentration and your attention immediately afterwards. Another thing, and we only found this out 3 or 4 years ago, amazing, in an area of the brain called the hippocampus, which is deep in the middle of the brain, which is very involved in memory and emotional management, we grow new neurons in our hippocampus when we've exercised. We carry out something called neurogenesis, partly linked to that BDNF, that brain-derived neurotrophic factor I mentioned, but also just because of the process of exercise, generating these neurons through different additional blood flow, etc. Now, more neurons in our hippocampus means better working memory, means better emotional management. So that's really important as well. And the other thing that exercise does is it increases connectivity between our prefrontal cortex at the front of our brain. That's the place of executive control. That's where we manage our responses and our impulses. That gives us the best version of ourselves, the one that doesn't eat the chocolate bar, even though we're desperate to. We carry on positively with our diet, and that's connected to our emotional system just behind. And what exercise does is increase connections between those areas of the brain. It also, in terms of physiology, supports our immune function, quite topical at the moment, and it supports better sleep as well, because what exercise does is it helps build up sleep pressure. So sleep pressure is one of the forces that send us to sleep. It's the buildup of a chemical called adenosine. And if we exercise during the day, that means we're building up more adenosine, more physical fatigue, which will help us sleep better as well. Okay, so we talked about habits. I talked about the mind a lot at the beginning. How do we get more of ROC2 into our lives? Or actually, in relation to any process, how do we change habits? Well, if we think of our mind as this kind of free floating space, this global workspace, neuroscientists refer to it, that place where we can reflect on our experience generated by the brain, we can take what we think is important and then go back into our neural architecture and change it. So we're carrying out sort of structural change on our brain. And how do we do that structural change? Fortunately, it doesn't involve scalpels or any kind of surgery. What it involves is habit change by physically changing the thoughts and feelings and activities that we're engaged in. And then we can slowly but surely build new neural architecture. So what's the most efficient way to build a new habit? Well, we need to regularize the habit before we can optimize it. What does that mean? We need to put it in our lives and then we can expand on it. So the best way for a lazy brain, and it's not just your brain that's lazy, mine's lazy as well. They really like to conserve energy. The best way for a brain to build a new habit is to have a very small time period to initially start doing that habit. So best to take small steps. We need some motivation to change a habit. So I want to get more exercise because I want to build those structures in my brain. I want to look after my cardiovascular system, build my core strength, etc. We've got to make it really easy. So the best thing to do is maybe do it for a short duration. And we've got to have a trigger in the environment, something that reminds us to do it. The time of day is probably the best trigger. And so a way of getting exercise into your life, and I did this about 8 months ago, and I've now got exercise in my life daily. And I'm a nerd, so I don't find exercise a great deal of fun, is to commit to exercise. Try this, commit to exercise for the next 7 days, every day, but just do it for 7 minutes, just 7 minutes of exercise. Now, if you put 7-minute exercise into YouTube, you'll find lots of free videos you can follow. There's an app that I use. I've put it on the screen. I'm getting no sponsorship from this app. It's just really useful. And the app version you can download is free. And it gives you a total body workout, like star jumps and stuff, for just 7 minutes. You just do it for 7 minutes. So you choose a time in the day when you're going to do that. I do it in the morning. So before breakfast, before a shower, just do your 7 minutes of exercise. It's over quite quickly, which is good for me because I don't really like exercise. And then you just do that every single day. And what you're doing is you're using your mind to go in and slowly but surely change the structure of our brain, because our brain starts to encode repeat behaviors. And if we repeat the behavior enough, it starts to encode that. And in a few weeks' time, you'll just come upstairs to do your exercise or wherever you do it. And just arriving at that place and that time will trigger that process of exercise. The other thing around exercise might be to commit, maybe to try and get your steps up to 10,000 steps a day, and build that in as a habit as well. And that will build that exercise habit. Don't forget that you can mix your rocks together as well. You can walk outside in nature while exercising. That's really good for us, listening to music, etc. So that's ROC2, exercise. That's what it does for our brain. There's some ways of getting it into our lives. I'm genuinely interested to hear your feedback. Loads of you have been writing back to me and giving me examples of what you're doing. People telling me about how difficult it is to build new habits in. I'm going to publish a new video on that again tomorrow. Do follow us on Twitter. We put out loads of stuff each day. We'll be back here next week to do ROC3, which is healthy food and eating, with a focus on the brain. And we're going to finish, as we always do, with one last inspiring video. And I'll come back for questions.
Are you scared yet? They say this thing, it kills your immune system, attacks your lungs, makes it hard to breathe, and it's spreading. Spreading like wildfire, causing havoc. Your friends and family are gonna get it, if they don't already have it. It's tragic, I tell you, madness. Scientists say old people get it worse, but most get it eventually. They say this is new, but no. This has been around for centuries. Look at history, it's just a different name, a different strain. And now there's no way to contain it. It affects the rich, poor, young, old, the unknown, the famous. It's dangerous. Everyone's on edge, locked inside of their homes nervously. Borders are closed, countries declare state of emergencies. Grocery stores are empty, nobody's praying in church. The world has gone to crap. No wonder toilet paper sold out first. The stock market crashed, thousands laid off work. Hand sanitizer is going for $1 million a squirt. You better not sneeze, because no one's gonna say God bless you. They might even arrest you. I don't mean to stress you, but washing your hands obsessively in the restroom will not protect you. Friends, I'm not talking about coronavirus. Now this is a virus even more deadly. The F virus. You've seen it. It spreads every minute like an epidemic. It lives on surfaces, most commonly remote controls, TV screens, cellular phones. It makes you desperate. Doctors say every time you scroll down your feed, you get reinfected. It invades the brain. And when it mutates, it turns into hatred and blame. China did it. No, Italy did. No, Iran, no Spain. Oh, I didn't make it clear? The F virus, ladies and gentlemen, is fear. But don't be afraid. Despite what you hear or see on your TV, there is good news during this tragedy. To fight loneliness, people are performing concerts on their balconies. The UAE sent aid to Iran. Japan donated supplies to China for free. Written on them was a poem that said, "We are waves from the same sea." Listen to me, like every tragedy, we can let this destroy us, or we can use it to our benefit and repair relationships with our sisters and brothers, wipe away silly grudges, because when it's all said and done, all we ever really had in this world was each other. So yes, let's flatten the curve and expand our hearts. Let's social distance, boost our immune systems, be mindful of where we put our hands, but also where we put our attention. Be alert, not fearful, because the F virus is a pandemic easily transmitted. If you contract it or exhibit symptoms, we recommend immediately dialing the hotline of a level-headed friend. If you are exposed through your TV, change the dang station. Decontaminate yourself through dance, laughter, and meditation. 2020 has been morbid. From Kobe to COVID, may we use these tragic moments to finally wake up to what's important. Right now, tell someone that you care for them. Yes, right now, tell them that you cherish them. If they are not in the same room, ring them up and tell them you will always be there for them. Because together is how we will rise above. The only vaccine for this F virus and every other virus is love.
So one last inspiring video. I'm just going to flick back to the 12 rocks so you can see the 12 rocks of well-being. Make sure you get the 12 rocks fitted in every day. And we'll be back here at 3:30 next week to do rock number 3. And if you loved it so much, we're doing it again at 4:30 today. I'll be around for a bit to answer questions, and I'll make sure you get this video. Thank you so much for coming along. Thank you. Bye-bye.